In the last episode, we looked at our concept, so let's have a little talk about why we chose this design. I said in the last episode that rule number 1 is that we are building an application before all else. This is true in the sense that there's little point building an entry that isn't going to stand out from the crowd, so this pretty much does rule out some weapon types from the off. I've got no way of knowing for sure, but I would guarantee that the producers for battlebots probably get more entries for spinners than they do every other robot type combined. I'm confident that if we were just going to build to get on the show purely, I could build a pretty out there, outside the box, unique machine. Like, if you want crazy, I've got some crazy. The challenge is trying to find the balance between something that is going to be competitive, something that's going to be unique and add a fresh perspective to the sport. Most importantly, something that I'm proud of and that I can be happy to stand behind. I think our electric hammerbot fulfills all of these requirements. There are also some practical reasons for deciding on this design. You can have your own opinion and you can say what you want about the end product of all of the Chinese fighting robot shows. They're really not to everybody's taste. They did, however, pay the robot builders a very fair financial stipend to go on the show, and it allowed me to buy equipment that I would not have been able to justify otherwise. So now I'm in the possession of some really high-end robot parts and materials, thanks to all that China money, baby! Many of these are going to be very well suited for my electric lance hammer bot. Me and Sabrina have recently returned from a holiday to the US and Canada. The name Jasper actually came from driving through Canada. I saw it on a signpost and I thought it sounded a little bit. While we was there, we also went to Disneyland. I'd been kicking the idea of this Buzz Lightyear themed robot around in my head for a little while. So while we was in Disneyland, I spent my time taking photos of things like the corners of buildings and light fixtures and the signs on toilet doors, because I like the design accent and I kind of like the details that they put in there. And I thought that it might look good taking some of that and putting it on a robot called Jasper. I also really like the game Fallout, so I've been looking at that for inspiration too, and I want to take it a little bit in that direction just to make sure it doesn't end up too cartoony and too poppy and too much of a novelty. I've put all of these images in one place so I can reference them easily. I guess we could call it a mood board, but I'd really prefer it if we didn't. So here's my list of fun inspiration ideas. For those that don't know, there is a comprehensive list of build rules that we need to follow for BattleBots. They exist either to put everyone on more of a level playing field, and they also exist to keep everyone safe. It contains things like safety requirements for the weapon systems. But the biggest and the most important rule and the most challenging rule is definitely the weight limit. So we need to be under or at 110 well, it's not actually 110 kilos because they don't do metric, do they? So it's 250 pounds, which works out to 113 kilos. So a little bit more. That's nice. So if we have a look at our list of wants for our robot, we're really asking a lot for that weight. The thing is, every team wants good drive and good armor and a good weapon. The challenge comes because you can't just have all of those things. You need to strike a balance because you need to be under that weight limit. If there wasn't a weight limit, obviously we'd just keep piling on things and end up with So to get all of these requirements and still be under the weight limit, we need to think outside the box a little bit, come at things from a different angle, maybe try some new things. One of these new things I'm thinking about is potentially brushless drive. Brushless drive is still relatively new in robots of this size, and it's still a little bit experimental and can be a little bit temperamental. I have seen some teams have some success with it though, so... Hello. This part here is a bit of a public service announcement filmed after some editing. There's a lot to consider when picking out DC motors, and quite frankly, I don't know what I'm doing. I'm aware there are power curves and you have to balance the motor's speed against the torque, against the load current. You have to really carefully tune your gear ratios to make sure you get the best performance out of the motor. There are a lot of unknown scenarios you can find yourself in robot combat, which makes this challenge especially difficult. The values you calculate are only ever going to be as good as your assumptions. That's true for anything. Without relevant background knowledge, my assumptions in this instance are pretty much just guesses. I happened to stumble upon a pretty near perfect setup of a system with the 48 volt long amp flows. I thought if I kept some of the key relationships in the system the same, so if I matched the
output power and the output torque and the ground speed,
I might be able to logic my way out of a fundamental lack of understanding and competency in this matter. I've never used brushless motors before, but they will offer a great deal more power to weight, so there are clear advantages in using them in Jasper. I just need to learn a little bit more about how they work. Anyway, back to robot parts. Let's start with the drive motors. The specs that the manufacturer or the supplier give us, they have a bit of a conflict of interest there because they're just trying to sell us something. Ampflo will sell you a smaller version of the 48 volt motors, which on paper seem like they would run a heavyweight, but they don't. Full disclosure, I know nothing about brushless motors, but it's okay, we'll learn together. So this is where we have to use a little bit of kind of guesswork. Just bear with me. We're going to ignore all the kooky units for a moment because we're just going to convert them all into SI. What I'm trying to look at is how much force we're putting down on the ground. This is our wheel. What we're trying to calculate is the force coming off at this point there, driven by this torque. What's the symbol for torque? Is it that? It's just to a T. Let's stop being clever. There is a gear reduction. So we're not actually applying the torque here, we're actually applying it through a little sprocket there, and then we've got a big gear running there, and the ratio is 6:1 reduction, 3.7 kilograms of force. Comparison, what I've done is I've had a look at the Maytech 4.1 newton meters. That made sense. That don't make sense! Have I messed something up? Well, we are nowhere near this value here. We're like a factor of 100 out. So I must be trying to compare apples to oranges here. So I need to probably learn more about the brushless motors. So I've done some more research and I've done some more reading, and I still am not quite sure what I'm looking at. I'm not an expert at speccing DC motors by any means. If anyone does know what they're talking about and can help me out, feel free, write some comments and don't hold back. Explain it very, very simply to me. So I did learn a little bit about how motors work because as a result of this as well. And with the short amp flows that I burnt out on the Griffin 2, it might have been a case that I just had them geared wrong. But if I had geared them right, I wouldn't have been able to accelerate quick enough to make them competitive anyway. So, whatever. Anyway, I've been doing some thinking and I think I've got a solution. So stay tuned, I have a plan.